In this lesson, we are going to learn how to define the response spectrum. Response spectrum analysis are calculating using the ordinate of the appropriate response curve, which correspond to the modal periods. Maximum modal contribution is combined in a statistical manner to obtain an approximate total structure response. So, to define the response spectrum, we first need to know the CA and the CV of our project. And to do that, you can use the tables in the code, or you can go to the load patterns, then choose any of seismic loads, then click modify lateral loads. As you can see, ETABS has calculated the CA, which is 0.24, and the CV, which is 0.32. Now go to the define menu, then functions, then click on the response spectrum. Here we have a previous function, so delete it by clicking delete spectrum. Now choose the UBC 97 code, then click add new function. I am going to name it spec UBC 97. Here is the CA and the CV, so I will take the CA equal to 0.24 and the CV equal to 0.32. Also here is the damping ratio, I will take it 5%. Then click OK. So we have defined the response spectrum function. Now we need to define this function into the load cases. So go to the define menu, then click on load cases. Here in this form click add new case. And here give it name spec-x. And the load case type is response spectrum. And here is the math source which we have defined before. By default it's defined here. And here under the loads applied, click on the add button twice. So here we are going to define the acceleration to the U1, which is the x direction. And here I will take the vertical acceleration U3. For the static method, we took the effect of the vertical acceleration as a percentage of the total dead load. But in dynamic analysis, I can add it directly here. And here I am going to choose the spec UBC 97, which we have defined before. Next is the most important step, that is applying the scale factor for the response spectrum function. So the formula for applying the scale is Ig divided by the R, where I is the important factor, which is 1 in our case, G is the gravity acceleration, and R is the reduction factor, which is 4.5 in our case. So in this text box, divided the G value by 4.5. And for the U3 direction, we can take it 2/3 of the U1 direction. So copy this value, then multiply it by 2, then divided it by 3. Under the other parameters, we need to select the modal case, which is modal in our case. And the modal combination method, I will choose CQC. And for the modal damping, I am going to apply 5% of damping, which is already being defined here. And for diaphragm eccentricity, I am going to take it 5%. Then click OK. So here we have finished assigning the response spectrum load in the x direction. Now I am going to do the same into the y direction. So click on add copy of case. Give it name spec y. Now under the load name, choose U2. Now click OK. Design codes often require that members be designed for 100% of the seismic loads in one direction and 30% in the orthogonal direction. So I need to add a combination case for the U1 direction and the U2 direction. So that select spec X, then click add copy. Name it spec XY. Now click on the add button. Then in the load name choose U2. Next, copy the U1 scale factor, then paste it into the U2 factor. Now click OK. Now I need tabs to include the vertical mass source in the calculation. So that, go to the Define menu, then click on the mass source. Go to Modify mass source, then activate Include the vertical mass option. Then click OK. The last step for our lesson today is to find the loop combinations for the dynamic analysis. So that, go to the Define menu, then click on Load Combination. Here in this form, click Add New Comp. Name it DYN1, then add for loads name. Choose the DID with factor 1.3, then the SD load with factor 1.3, then the live load with factor 1, and the last one choose SpecX with factor 1. Then click OK. Now select DYN1, then click Add Copy of Comp. Name it DYN2, then select SpecY, then click OK. Again click Add Copy of Combo, name it DYN12, then select SpecXY, then click OK. Now I am going to add the secondary combinations. So click Add New Combo, name it SDY1, then add 3 loads. The first is the DID load with factor 0.9. The second is the SD load with factor 0.9. And the last one is the SpecX with factor 1. Then click OK. Next, copy it, then name it SDY2. Then select SpecY. Then click OK. Again click Add Copy, name it SDY3. Then select the SpecXY. Then click OK. Now I have finished the load combinations for the spectrum analysis. So I am going to run the analysis. Now it is the end of our lesson. In the next lesson we are going to do the essential checks for the response spectrum analysis. So hang on for that.